Hello, it's Hong here. I made this video to help guide you through the process of analysing the raw data collected from the caffeine experiment in your practical. What I have here is some dummy data, and the spreadsheet you would have downloaded from Canvas is also structured in the same way, so we can work through our datasets at the same time. Now recall that the research question that you are wanting to answer is something like, does the consumption of caffeine enhance aerobic performance? We had two groups, currently labelled A or B, and they were named this way because the experiment was done in a blind trial, which meant no one, including the data collectors or the demonstrators, knew which group drank caffeinated coffee and which group drank decaffeinated coffee. The other columns contain the data that was collected. So we've got the resting pulse rate before the coffee was consumed, the resting pulse rate before the step test was done, and then the final pulse rate after the step test. And we all have the units here, which is important, which is beats per minute. In biology, we usually look at the population response. So the means and some measure of variability would be of interest to us. And we want to calculate these values for each treatment group. So notice in the spreadsheet that the data is not sorted by group, which is not very helpful. So the first thing we're going to do is sort our data. So we're going to select the columns that contain data, and what I'm doing here is selecting any one of these cells that has a number or a letter and selecting on my keyboard Command A. So it's Command A for me because I'm using a Mac, but if you're using a PC, then press Control A instead. So after this, go to the top menu and select Data, and then select Sort. So this pop-up window appears, and you have a few choices to sort by. So for us, we want to go by group. Okay, the order from A to Z, which is fine, and then select OK. Okay, so now all the data for subjects in group A are at the top, and all the data for subjects in group B is below that. And notice as I scroll down the spreadsheet that the headings have disappeared. And if you don't like that happening, there is a nifty function to prevent it. So all you have to do is scroll up to the top, select row 2, because that's the row underneath the headings, and then at the top select View, and then Freeze Panes. So then when you then scroll down to the bottom, those headings stay put. The next thing to do is to move the data for Group B over next to the data for Group A, and that will make our lives easier when we get Excel to calculate the means, the sample size, and the standard error for us. So first, let's copy these 3 headings. Select them with your cursor, and because I love keyboard shortcuts, I'm going to press Command C on my keyboard to copy, and in the cell where I want to do the pasting, I then press Command V. I'm using a Mac here, but if you're using a PC, your keyboard shortcuts are Control C for copy and Control V for pasting. I'm also going to include a new row above these headings by right-clicking on row 1 and selecting Insert. I've done this so I can include another heading to remind myself and anyone else who would look at my spreadsheet that the data in these 3 columns belong to Group A, and the data in the next set of columns on the right is for Group B. Just to make things neat, I'm going to merge the cells from C1 to E1, and under the Home ribbon, you can select Merge and Center. I'll then type in, well, I could say Group A, but then this was just a label that we used in the study because it was a blind test. When you talk about your treatments in your report though, referring to them as Group A or Group B isn't really informative. it actually won't mean anything to the reader. They don't care for the final logistical details, so you won't even need to mention Group A or Group B anywhere in your report, not in the text, not in the figures or any tables. What is informative though are the actual experimental treatments, which in our case was caffeinated or decaffeinated coffee. So go ahead and type in that information in the merged cell that we created. In my case, it will be decaffeinated coffee. But for you, it might be different, so just double check the information in this cell in your spreadsheet. And do the same for the set of columns on the right. For me, I will type in caffeinated. And I'm going to bold the headings because I like to do so. Now I can finally copy over the data from Group B and paste it under the new headings we created. So go ahead and use your cursor to select and drag your selection over the cells containing the data from Group B. Now, dragging the selection works fine here because pretty much all the data that I want to copy fits inside my screen. But say if you work with a much larger data set, especially if it spans over hundreds of rows and columns, it can be quite inefficient to use this strategy. So I have a trick for you in this case, and that is to click on the cell sitting in one corner of your data set, and then scrolling down or across to find the cell sitting in the opposite corner diagonally across from the cell that was just selected. Then press the Shift key and keep holding it while clicking on the cell sitting in the other corner. Now this method is more ergonomically friendly, and I think you're less likely to make mistakes with your selection. So okay, go ahead and copy and paste your data across. And then we can delete the rows sitting at the bottom here. So select, right click and delete. We also don't need the column with the Group A and Group B labels anymore, so we can delete that column as well. We also don't need the replicate numbers, but I would still like to keep column A for another purpose. So instead of deleting it completely, I'm going to clear the information. So I'm selecting the entire column, right-clicking, and then selecting clear contents. So then I have space to include new labels. And so what we're going to do is type in, let's start with sample size, followed by the mean, and finally we've got standard error, which is often abbreviated as SE. Okay, so these are the parameters that you need to report in, or you need to report in the written description of your results section. Now, the sample size is just the number of replicates in each of your treatments. Okay, so in Excel, there's this function called count, and so we're going to command Excel to count how many replicates there are in each of the treatments. So then, when you get Excel to do a command, it always begins with an equal sign. So type in equals, and then type in count. It doesn't matter if it's lowercase or uppercase. And then open brackets. Okay, so then Excel then tells you to select your values, okay, or select the cells that you want it to calculate this function for. So then you can go and select all the cells under row B, excluding the heading. So what I've done here is I've selected the bottom cell. So I'll just do that again. I've selected the bottom cell, and then instead of dragging my cursor up, I'm pressing down on the Shift key and then just selecting the top cell that contains data. And so that way Excel selects all the cells, all the numbers between your bottom and your top selection. Okay, then finish off the function by including your close brackets and then enter. Okay, so in my case, I've got a value of 21, so that tells me that I have 21 replicates in my treatment. Okay. Now, you can input the same command under each column, but that's a bit of a time waster because Excel is smart in that you can copy over the commands across the columns. So select the cell that you just calculated the sample size for, and then hover your cursor over the bottom right hand corner. Okay, then you should see a black cross. Click on it and then drag your cursor over. Whoops. And I keep dragging over. Okay. To calculate the mean, input the command equals average, open brackets, and again select your raw data. Okay. Make sure you don't select the sample size value that you just calculated. Okay. Again, then select that cell, hover your cursor over the bottom right hand corner, and then just drag that formula across. Okay, so you don't have to be calculating these values yourself or repeatedly. Now for standard error, the command is stdev, open brackets, select your raw data in that column, close brackets, but don't press enter yet. What you then have to do is type in a / followed by an sqrt, which stands for the square root, open brackets, and then select your value that represents the sample size. Okay, and then close brackets, and then enter. And then again drag that formula across. Right, Excel always gives your numbers to, I don't know, a gazillion decimal places, which really is not helpful for us. It's not informative and it's really unnecessary. So what we're going to do is select those cells that contain the means and the standard error. And then we're going to go up to the top here. So there's these two buttons that will change the number of decimal places for you. Okay, so I want to decrease the number of decimal places. And for us, to 1 decimal place is enough. Okay. Now you have the choice between presenting the means, the standard error, and the sample size in a table or in a graph. I would recommend presenting the data in a graph, but you are of course free to ignore this advice, and if that's the case, you don't need to go any further in this video. Just transfer these values into a table for your report and make sure you have appropriate headings and that the table is accompanied by a table caption. If you want more information regarding this, refer to the writing guidelines for this report. Now, for those who decide that having a data presented in a graph is the best way to go, I will show you how to create a column graph because it offers a visual representation of the data and allows for easy comparison between multiple values across different categories. In our case, the categories are the different coffee treatments, so decaffeinated and caffeinated coffee, and we can also make comparisons across different time points at which the pulse rates were measured. So these time points are what we're labeling as pre-treatment, that is before the coffee was consumed, post-treatment, 1 hour after the coffee was consumed, and post-exercise, which was after the step test. We will tell Excel that there are two subsets, or what it refers to as series of data. And so we have one series of data for the decaffeinated treatment and another series of data for the caffeinated treatment. Now there are multiple ways to create a graph in Excel and format it, and every guide you come across will show you how to do it a little bit differently. I'm just going to show you one method, and the way I'm going to do it is to go to the Insert tab up at the top and then go over to the Chart section and select the icon that represents a column graph. You will be presented with a few options, but select the clustered column in the 2D version. And let me just try that again. Oh. You're just going to make sure that none of the cells, including data points, are selected. So let's try this again. Go to Insert and select a clustered 2D column, and this is what you should see, a blank canvas appearing on top of your data. It's blank at the moment because we haven't linked it to any data from our spreadsheet. And before we do that, let's just move it out of the way so the means and standard error are accessible. So I'm just going to move it to the bottom here. Alright, so you then, anywhere on the blank area, right click and choose Select Data. So a pop-up window like this will show up. It might look different to you depending on what Excel version you have, whether it's whether it's 2016 version, whether you have a Mac or a PC version. What we're looking for is a place to enter our two subsets of data or series of data. You should be able to see a box for X values, another box for Y values, and then down here something that reads like horizontal category axis labels. Let's get Excel to link our data with the chart area. First click on the plus button and something called Series 1 will appear. That's a default name which isn't very informative, so let's change the name in this box. The order of the treatments doesn't matter here, but I'm going to be, I guess, conventional, going from left to right. So I'll add in the data from decaffeinated treatment first. Therefore, I'm going to override the default name to decaffeinated coffee. So I'll type that in that box. Alternatively, you can get Excel to link this box with a cell that already has text in it. So if you click on this icon with the red arrow in it, and then select the cell that you want. Oops, let me just try that again. Select all that, select the icon, then select the cell. And then if we clicked OK, you can see that the label in the graph is exactly the same as the text in the cell that you selected. I guess the advantage of this function is if you make any updates to the cell that you've linked the graph to, let's say I change the name to decaffeinated coffee instead, then those updates will automatically show up in your graph. We need to go back into the Select Data window to finish off our graph. So right click anywhere on the background of your chart, just make sure it's not the grid lines, and go to Select Data. We need to tell Excel what the Y values are. In this case, they are the mean pulse rate values taken across the 3 different time points. Again, click on the icon with a red arrow and select the mean pulse rate values for that treatment, which in my case is decaffeinated coffee. Then click on the icon with the red arrow. And before we close this window, let's add in our second data series, which in my case is a caffeinated coffee treatment. So make sure you add in an appropriate name. and you tell Excel what the Y values are. Again, this is going to be the mean pulse rate values across the 3 different time points for that particular treatment. Not that row. That's what we want. Okay, so let's see what we have so far when we click OK. I can see that my graph has 2 sets of data, one represented in blue and the other in red, but I don't know which one represents the caffeinated and the decaffeinated coffee treatments. What I need is a key. Excel might call it a legend. Depending on the version of Excel you are using, that key or legend might already be present. It's not in mine, so I'm going to have to add it in. So I need to go up to this tab called Chart Design. If you don't see this, then it means you haven't clicked on your graph. So go ahead and do that. Anywhere on the chart is fine. Then go to Chart Design, go to Add Chart Element, and hover your cursor over the legend. I'm going to choose to have my legend on the right hand side because that's my preference, but you can have it anywhere else on the graph if you wish to do so. Now the reader can see that the blue columns represent the decaffeinated treatment group and the red columns represent the caffeinated treatment group. You can choose to change those colours, but don't get too carried away because there is still work to do that would actually add real value to the overall presentation of your graph. So the columns represent the mean values, and we're presenting the means because we are interested not in the individual responses, but the overall response in our sample population of university students. Whenever you present means in a graph, you also need to include error bars to represent some form of variability. You may have heard of ranges or standard deviation, but in biology it's very common to use what is known as standard error. I'm not going to go into the detail over the differences between each kind of measure of variability and when it is more appropriate to choose one over another, but it is enough for you to understand that the smaller the standard error, the closer the mean of our sample population, that is the subjects used in this study, is to the mean of the actual population, which would include all the other existing university students. To add in error bars, click on one set of the columns. Then go up into Chart Design, then Add Chart Element, and hover your cursor over error bars, and then select More Error Bar Options. This panel on the right should then appear. You might also notice that Excel has included some error bars for me. It thinks it's smart and knows what I want the error bars to represent, but it doesn't. So we actually need to select Custom down at the bottom here on the right hand panel and then specify a value. So then this pop-up window should appear. We need to set both the positive and negative error values to the 3 standard error values calculated for that particular coffee treatment. So go ahead and do that. Then click OK. Now I have the error bars that actually represent standard error. Make sure your graph shows both the positive and negative error bars. And in terms of the end style, it is up to you, but it's my preference to have caps, so hence I've selected this option. You'll need to do the same thing for your other set of columns. So Chart Design, Add Chart Element, Error Bars, and More Error Bar Options. Then go into Custom and specify value. So we can get rid of the grid lines as they just create clutter in our graph. So you just need to click on, so what I did was I just clicked on one of them and then I selected delete on my keyboard. You can also see that I don't have any informative axis labels. The default for the x-axis labels are just numbers, as you can see here. To change that, find an empty cell nearby and enter in the labels that you want to appear on your graph. So let's use pre-treatment, post-treatment, and post-exercise. You'll then need to right-click on the background of the chart and go back into the Select Data window. Then link the horizontal axis labels to the text we just entered into the cells. Then click OK. Let's also add in an x-axis title. So click anywhere on the chart, go up to Chart Design, Add Chart Element, then select Primary Horizontal Axis Title. And I'm going to name this axis title as Time. You might have noticed that I have a habit of bolding titles and headings. You don't have to do that, but if you do and weren't aware of what keyboard shortcut I was using to bold the text, it is Command B for Mac users and Control B for PC users. The last element I'm going to fix up in this graph is the y-axis. Firstly, I don't even have a y-axis line, and this is usually the default in the most recent versions of Excel, which is kind of annoying when creating scientific graphs. So double click any of the numbers in the y-axis, and then that panel on the right should appear again. Select the paint icon, and you'll need to override the default setting for the line. So at the moment it's automatic, so I'm going to choose solid lined. And make sure you have an appropriate color for your line. So grey or black would be appropriate here. I'm also going to polish up the numbers on the y-axis. Here they are to 1 decimal place, and if you go into the numbers setting, so you click on this graph icon and then go into number, you'll see that this option called link to source is checked. We had calculated our mean values to 1 decimal place. Hence, the values in our graph are also to 1 decimal place because this option is checked. So if you uncheck this, and then up here, set the decimal places to 0, that should also change the format of the values in your y-axis. So by doing this, it makes your graph look less cluttered. You can also declutter the graph by changing the increments in your y-axis scale. Here I have 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers on my scale, which is a bit of an overkill. It's not terrible, but it definitely looks cleaner when you limit it to 5 to 7 numbers. So I'm going to go into the Axis options in the right panel, and under Units, I'm going to change the major increments to 40. Finally, I'm going to include a y-axis title. So again, go back into Chart Element and select Primary Vertical Axis Title. In some other versions of Excel, this might actually be called the Rotated Vertical Axis Title. Give it an appropriate name. So I'm going to call it mean because we are presenting the means. So mean pulse rate, and make sure you include the units, which in this case is beats per minute. Make sure the text in your graph is legible. You can change the font size by clicking anywhere on the background of the graph. going to Home, and then adjusting the font size. So let's make this 11 for example. Okay, and then you can also adjust the size of your overall graph. When you do this though, like changing the font size, sometimes your bolding will disappear, so you have to reformat them again. My last piece of advice is to save your graph as an image. So right click on the background of your chart and select Save as Picture. The best formats for this is either PNG or PDF. I find JPEGs produce low quality graphs, especially scientific graphs. And so anyway, you just need to then slot that saved image of your figure into the report. Okay, so there you have it. I hope you found this how-to guide useful, and if you have any questions regarding the processing of your data in Excel, don't hesitate to post them on our discussion board. See you next time.